hope it's audible.
Good morning, sir. It's
Okay.
audible.
All right. So welcome you all to this session on the introduction to Six Sigma. Previously, we were saying quality measurement and quality management in healthcare industries. So as a part of the same continuing sessions, we also have in the syllabus the concept of Six Sigma. So as you can see, Six Sigma is a performance goal representing 3.4 defects for every million opportunities to make one. So after reducing so many defects or mistakes, they expect that out of every million opportunities, there should be only 3.4 defects. That's how, due to some serious research, they have come to this conclusion. So they are having a lot of tools and methods used to improve the design, the products, and the processes and the services. So while designing all these things, the entire design element should make sure that the mistakes and the defects should be reduced to as minimum number as possible, and it can reach 3.4 according to some standards. So the another point is a statistical measure indicating the number of standard deviations within the customer expectations. So Six Sigma measures whether the quality of service which is being offered is as per the expected standard or is it deviating, and it will measure and count them. Six Sigma is also a disciplined, fact-based approach to managing the business and its approaches and its processes. Basically, to see that there is some amount of control and statistical significance in whatever activities the healthcare industry is utilizing it. In fact, this also has come from manufacturing industry only. It is more challenging to implement this in healthcare settings, but then many hospitals are trying to implement this. So the today's agenda will include the understanding of the Six Sigma, history of the Six Sigma methods and tools, and roles and responsibilities of the people, and how you can use them. So let's begin. As I was telling that it is more or less based upon the Japanese kind of philosophy, wherein they have inculcated various phenomenon and the philosophy for systematically improving the quality and therefore efficiency. A standard of performance equal to 3.4 defects per million outputs, that is almost near the perfection. So most operations are about 2.8. Okay, very good operations in the sense the transactions which I'm talking, it's are about 4 sigma, that is 3,500 defects per million. So some of them are good at 2.8, some are having 4. So it could vary, but at least starting to measure how many defects are there in the providing the services and the products is much more important. So basically, it is having a statistical control, and it is a newer way of business. It is an application of statistical tools within a structured methodology in order to find out the feedback given by the customers, or in this case, the patients. So it is repeated application of the strategy to the individual projects. So again and again, if the mistakes are repeatedly happening in the organization, we should be able to count them and put it under mean, measure, mode, and deviation, standard deviation. All these measurements are being stored in and documented for the ratings purposes. Then the project selected that will have a substantial impact on the bottom line. So time, quality, and cost, all those things could be saved. So again, it is a scientific and practical method to achieve improvements in a company. It is a structured approach, and it assumes quantitative data. Okay, it has to see some verifiable data which is quantitative to measure, And the practical implications could be emphasis on the financial results. So somewhere or other down the line, it should reflect in the profit and loss account and balance sheet, and should start with the voice of the customer. It means people have to authenticate that there has been a significant improvement in the quality. So which all industries the Six Sigma can be implemented. So on the left hand side, you can see it could be implemented in administration areas, in middle and top level management, in the service industries, even in design of certain products, it could be used. Even in the purchase department, it can be done. In the production lines, in several manufacturing units, it could be done. It could be done in IT industries and mergers. It can be done in HRM. Sorry, it's not merger. It's marketing and sales. It could be done, and then you can implement them in HRM. Then you also have a quality department, which is very critical and essential for every organization, wherein you can implement the Six Sigma methods. So in almost all kind of industries and all kind of verticals, or even that matter, the functional areas, including the core operational areas also, Six Sigma can be introduced. So the Sigma is a letter, it is a Greek letter or the Greek alphabet, what we call. It symbolizes the degree of variation. And it is a level of measurement of the performance of the individuals concerned in specific departments in terms of how many times they are finding faults with any kind of products or services. It is also the statistical measurement of process capabilities, and it has benchmark for comparison. So you can have a comparison across various industries if you arrive at that statistic. It is also a process for improving the methodology. Basically, it is a goal of the organization, the long-term goal, you can say, based upon the mission and vision. Why the organization exists is a mission, and what is going to become in the future in the next 5 years is a vision. Because vision also has to be always futuristic, and mission is what is there in the present. And derived from that vision and mission is the goal. And in order to achieve those goals, we are implementing Six Sigma as a methodology. Basically, it is a strategy to beat the competitor so that you're much better off in providing your services as compared to any other organizations of the same repute. Next, it's a commitment to customers to achieve an acceptable level of performance. So, since the data is collected from the customers themselves, you are going to have some amount of authenticity in terms of what services were offered to them. So, it is not something based by third party consultant, or it is not something decided by the board of directors or even the employees themselves. Okay, it is a statistically measured, and feedback is obtained from the end users. Sigma is a measure of variation. Mu is a horizontal line. Sigma is a deviation, what you can say. It is a variation. So this is a bell curve, and how many times this kind of mistakes have happened, it is going to measure. So again and again, if the mistakes are happening, it could be counted. Rather, instead of calling in mistakes, we normally call it as defects or faults in providing production services. So what this variation actually means? Okay. So variation means the process does not produce the same result every time. Sometimes it depletes down the line on somewhere -5. Then again it increases to +5. Then again 1, 2, and again 0, 5, 10. So you have to come to an average. So on a daily basis, if you can say, on some days which are good days, you find good services or good products as far as standards are concerned. Then again, on some days, it will be depleting. So it's an ongoing process. We just have to watch for it. So some variation will always exist in the process. Variation directly affects the customer experiences. But the problem here is customers do not always feel the averages. Okay. Customers are not bothered about that our average is good or not. Customers will only complain when there is some defect happening too many times in a day. So let us say the current switches off or the fuel prices are too much to bear, or the billings, there are so many errors, or there may be other kinds of human errors or technical errors which are noted down here. So we cannot get away with this kind of variation, but all that we can do is to find an average. But customers or the patients are not feeling those averages. It's we, the organization, which who we have to know where do we really stand. So in this case, above 5 but below 10, this is the average which we are able to find out. So this could be any kind of faults. It could be administrative faults or record keeping fault, documentation faults, in terms of customer expectation, sharing of whether the treatments given were effective or not, or even the billing procedures were fast enough, quick enough or not, or the payment methods were nice enough, or people who are providing courtesy in order handle that went out smoothly or not. So it could be measured across the departments, as we have previously told. It need not be restricted to only one department. It will share the overall findings from the feedback taken from the patients. So the best in point to begin with is the case of your Domino's Pizza, which guarantees 30 minutes or less time to bring it or deliver it. So what if we measure the performance and found an average delivery time of 23.5 minutes? Although they are promising 30 minutes, they could deliver in 23 minutes. So someone who is not so rationalistic came up with an idea of delivering within 10 minutes, which we all know that is not practically possible unless the place is too close. Even after going to the restaurant, we normally have around 15 minutes to get the pizza arranged with the packed and accompaniments and all. So on time performance is great. That's what we call by implementing Six Sigma. But our customers must be happy with that, and there should not be too many hazards or things which are at risk for the people who are on the job. So it all began with a simple example from a food service industry. So it will just measure. So 30 minutes or less, we have to decide this is the vertical line. Okay, so managing by the average doesn't tell you the whole story. We need all the people to deliver within 30 minutes, but in every instance, it may not happen that. The average and the variation together show what's happening. You should also take the average and what is on a day-to-day basis you can have. So somewhere down the line, you can measure. So how much of variation can be looked at. And Six Sigma level measures often we meet or fail to meet the requirements of our customers. So how many standard deviations can you fit within the customer's expectations? Okay, there are how many things over an average, right, from administration, billing, patient care, and safety precautions, courtesy. How many standard deviations can you come across? That one has to be able to be identified. So currently at Six Sigma level 1, 30% good, 69% bad. Six Sigma level 2, 69% good, 30% bad. Level number 3, 93% good, 6% bad. 4, 99.38% good, 0.62% bad. Like that it goes on. So the good is going to increase like this, 99.977%, 0.023%. And here the sixth level of Sigma level number 1, 2, 3. It takes number of years in order to reach those standards because there are things that doesn't happen all of a sudden. So defects per million we call DPMO. So earlier the defects were too many. Okay, now the defects has come to 3.4 like that. Over a period of time, defects will be reduced to almost 3.4 defects per million activities, you can say, or operations. Now, the example of Six Sigma in a world of three Sigma, previously at least around 20 years ago, we can say, there are 964 US flight cancellations per day. Many people are canceling those flights. Okay, in a world of Six Sigma, one US flight is cancelled every 3 weeks. Okay, you can see the limit per day. 964 US flights used to be cancelled. Flight cancellation I'm talking about. Just to give an example, one US flight is cancelled every 3 weeks. So there is one flight which is cancelled every 3 weeks. Somewhere or other, it has come to that level. But of course, the risk and hazards are increased over a period of time. at least for the last 6 months. The reasons of which they are still able to identify either older older aeroplanes or something like that. Then another example from the social services security is the police makes 7 false arrests every 4 minutes. This is a US example. There are fewer than 4 false arrests per month. Okay, every 4 minutes, 7 false arrests used to be done. Now, even during the month, only 4 false arrests are done. So, in Massachusetts, 5,930 newborns are dropped each year. Here, one newborn is dropped every 4 years. Next, in 1 hour, 47,283 international long distance calls are accidentally disconnected. That was when everything was connected, even can say before the new generation of smartphones came. Now it would take more than 2 years to see the same number of drops from international calls. If you call, there are lesser chances of getting it disconnected. So these kind of Six Sigma implementations across this communication industry, in case of healthcare, as you can say, or pregnancy rates, or this kind, and the police and the flights. These are the examples of Six Sigma, whereby in a world of Three Sigma, it was like this. There were so many mistakes and errors which people used to face. They were hardships. They used to have a lot of toiling, and people used to really slog a lot in order to overcome these barriers. Now, because of implementation of Six Sigma in various industries, the number of mistakes which the current generation faces is significantly lesser because of Six Sigma. So Six Sigma definition says is a breakthrough strategy to significantly improve the customer satisfaction and shareholder value. So shareholders should be interested in order to invest in the organization by reducing the variability in every aspect of business. Okay, not just one aspect, but most of the aspects of business. People should feel happy in order to invest in those companies. And this strategy is going to support the organization overall, so that if it is implemented in every aspect of business, people will try to measure and get a statistics at the end of the annual report by reading them in close detail. So all these venture capitalists and companies which are starting and expanding their units are most likely to go through this, whether there are any systems in place so that they're able to know how many mistakes or how many faults they're facing with. So the technical definition of Six Sigma is a statistical term signifying 3.4 defects per million opportunities or million operations or activities, whatever you call. So basically, every opportunity in every aspect, administration, sales and marketing, HR, okay, finance, everywhere, should normally come to around 99%, as we just now saw. So 3.4 defects can be allowed at the maximum for every million. Million means 10 lakhs opportunities. Now that was about understanding Six Sigma. Now let's go to the history of Six Sigma. So in 1818, Gauss uses a normal curve to explore the mathematics of error analysis for measurement, probability analysis, and hypothesis testing. Okay, so same year where India was annexed to the Britishers, 1818. Then we got 1924. Walter A. Shewhart introduces the control chart and distinction with special and common cause of variation, 1924. So before that, we are having 1896. Italian sociologist Wilfredo Alfredo Pareto introduces 80-20 concept rule, whereby the Pareto distribution occurs in the course of the economy politique. So he introduces that 80% of the mistakes committed by organizations is surely out of only 20% of the kind of faults, whereas 20% of the remaining faults are created due to 80% of the identified reasons. That's what has been identified long back in 1896 by Italian sociologists. Then 1924, as just now saw, Shewhart introduced the control chart was introduced for the first time to have a special cause or a common cause to identify them. Then in 1736, French mathematician Abraham de Moivre publishes an article introducing the normal curve. So the bell curve, which we call it as a normal curve, he introduced in 1736. And of course, this should have been told first. This okay, by mistake I am coming here technically, but this is way back in 1736. He found out what is a normal curve in all the activities or opportunities. Then in 1818, Gauss used this normal curve to explore the mathematics of error analysis and measurement and probability analysis. Then comes a Pareto in 1896. Then 1924, Walter Shewhart. Then comes 1941, Alex Osborne head of the BBDO advertising, fathers a widely adopted set of rules for brainstorming. So uses all the committees or analyze all mistakes. Then 1949, US DoD, Department of Defense, issues a military procedure, MILP 1629, procedure for performing a failure mode effects and criticality analysis. It was introduced in the military by the US in 1949. We are telling a Six Sigma evolutionary timeline. Then comes our 1941, okay, fine. 1960, Kaoru Ishikawa, he's the most prominent scientist from Japan. He introduces his now famous cause and effect diagram, the fishbone diagram, wherein you write a fish diagram and the bones and the tip of the fish tongue. We are going to write the problem, one problem at a time, and the bones are determining whether it is a human error or a mechanical error or technical error or IT error or HR error or sales error, whatever it is. So Kaoru Ishikawa was a person in 1960. Then 1970, Noriaki Kano introduces the two-dimensional quality model and the three types of quality which we have to adhere to. Okay, several dimensions of the quality. What do you mean essentially by the quality? It was determined in 1970s. Then 1986, Bill Smith, a senior engineer and scientist, introduced the concept of Six Sigma at Motorola. Then in 1994, Larry Bossidy launches Six Sigma at Allied Signals Corporation. In 1995, Jack Welch launches the Six Sigma at General Electric. Hello. Yeah. So right from 1736 onwards to 1995, we have a series of developments on the Six Sigma evolutionary timeline. So many people from France, Italy, US, UK, and Japan have been introducing and evolving these concepts over in the industry, and it is implemented in several industries. As we now saw, there were so many mistakes which were happening previously, and they have been significantly reduced. So the companies in which this has been already tried and tested is General Electric, Ford, Honeywell, John Deere, Johnson & Johnson, Kodak, Lockheed Martin, ServiceMaster, Raytheon, Miracle of Science, Black & Decker, Sony, Motorola, Caterpillar, GM, Allied Signals, and Dow. JP Morgan Chase, Merrill Lynch in financial services, State Street, American Express, AIG, Citigroup, Countrywide Financials, Deutsche Bank. All these are in financial services. So it's not necessary that only one manufacturing have to be used. It can be introduced into financial services as well. Then, after having seen a little bit brief about the history of the Six Sigma, then now try to understand the tools and techniques which are being used in the methodologies contained thereof. So basically coming back to the same thing probably in the last one of our sessions, I have already introduced this method to you. That is define. So somewhere or other down the line, we have to be able to measure what is the meaning of a certain activity. So define the tools like cost of poor quality. What do you mean by poor quality? What do you mean by good quality? Both the ranges of minimum and maximum you have to set up. Then voice of the stakeholder. You have to take the either voice of the stakeholder in terms of the feedback on a scale of 10 or a scale of 5. Then VOS, voice of the stakeholder, right? Press 1 for this, press 2 if you are happy, press 3 for this if you're not happy. So this is known as voice of the stakeholder. Then project charter. You should have some guidelines, rules and regulations. The charter has to be noted down and should be launched. Then as in map process, whatever map is showing, that has to be mapped down. Like it should not be resisted, or the communication should not be hidden from all the concerned people, from top management to newcomers. Primary metric has to be set. So what should be the standard? Whether like in case of pizza, they're telling you how many minutes within 30 minutes or 20 minutes, everything should be standardized. At least some expected norm everybody should know. It should not work without any boundaries. You should have some boundaries. Next, measure current performance. Currently, how far is successfully the patients are being happier on terms of fulfillment of the requirements. So critical to quality requirements, CTQ, what is important for them? Okay. Okay, it could be consumables, disposables. It could be the treatment given by the nurse. It could be number of visits done by the doctors. It could be number of beds available and number of accompanying people. Okay, anything that has to be merely important as far as even hygiene and cleanliness of the place, ability to talk courteous with the courtesy